All right, so today we're going to look at transformations of trig functions. F of x equals a sine of bx, and f of x equals a cosine of bx, where a and b are any real numbers. Okay, so we're taking the original sign and we're transforming it by multiplying the function by a, multiplying x by b. Same thing for cosine. All right, so when we multiply by another number other than 1, we're going to see a vertical stretch or shrink. And the effect will be the original coordinates will be multiplied by that a, the y coordinate only. Okay, and then b produces a horizontal shrink or stretch, and the new coordinates will be the result of the originals divided, the x value being divided by b. Okay, the absolute value of a is called the amplitude. Okay, and we'll take a look at what the amplitude is. Some of you may remember from geometry, amplitude is another word for height. Okay, but we'll talk about what that means for our sine and cosine graphs. All right, since the period of the function is normally 2 pi, both sine and cosine, original function was 2 pi in length, so when we transform that, we're going to do 2 pi divided by b. Okay, all right, so let's take a look at how that's going to play out. So we have here, we're going to finish the graph from negative 2 pi to 2 pi. The new function is 3 sine of 2x. Okay, so the period is going to be 2 pi divided by b, and in this case b is 2, so 2 pi divided by 2 is simply pi. The amplitude will be the absolute value of a, so the absolute value of 3 is 3. Okay, so we're going to divide by 2, and we're going to multiply the y value by 3. Okay, now when we get over here and we say we're going to divide pi over 2 by 2, it gets a little weird looking. So I just want to remind you, pi over 2 divided by 2 could also be written as pi over 2 times 1/2. Okay, so as you're going along, if it's easier, just write times 1/2 rather than dividing by 2. But we're really going to divide all of those by 2, and we're multiplying the y value by 3. Okay, so 0 divided by 2 is 0. 0 times 3 is 0. Pi over 2 divided by 2, okay, is going to actually be pi over 4. And that will be 1 times 3 is 3. Okay, pi divided by 2 can be left as pi over 2. And 0 times 3 is 0. Okay, 3 pi over 2 divided by 2. Okay, that one I'm going to bring off to the side. 3 pi over 2 divided by 2. It's going to be 3 pi over 2 times 1/2, which gives us 3 pi over 4. And then negative 1 times 3 is negative 3. 2 pi divided by 2 is pi, and 0 times 3 is 0. Okay, just want to point out here, because this was the original period for sine of x. This is one complete cycle, right? And when we did this, when we did the transformation to the points, we ended up here at pi, which is what we said our period would be. So now instead of going all the way to 2 pi, right, we'll have completed a cycle in pi. Okay, the amplitude is going to be 3, and as you can see, the highest and lowest points for our y values are at 3 and negative 3. Okay, so if we graph these points, 0, 0. Pi over 4. Pi over 4 was the tricky one to find because we're counting by pi over 6. So pi over 4 is halfway between pi over 6 and pi over 3. So that's going to be pi over 4, and then we're at 3. Okay, pi over 2 is at 0. 3 pi over 4 is going to be halfway between our 2 pi over 3 and 5 pi over 6. Okay, and we're going to go down 3. And then at pi, we're back to 0. Okay, so you can, when we graph this, right, and this is a little tricky, this program for me, using this pen's a little bit hard. So this isn't the best curvature because we should see a little more symmetry on there. Okay, but this is one complete sine cycle. That's the shape we want. We know that sine looks like. It's been vertically stretched and it has been horizontally shrunk. Okay. All right. So now it says we're supposed to go from negative 2 pi to 2 pi. That we've only gone to pi, so we're going to have to repeat this. So if we pick this whole thing up and moved it over, right, this point is now here. So we would expect our next point to be the one that was related to pi over 4 and 3. So we'll go a distance of pi over 4 from our current location, so it's about there. And we're going to go up 3 and place our point. Okay, 3 pi over 2 is pi over 2 in this instance. So we're coming back to 0. And then go halfway in between to go a distance of pi over 4. We go down 3. Okay, and then back up to 2 pi. So we have this nice wave motion going on. Okay. All right, now to go to the other side to get to the negative 2 pi portion, because we're supposed to go to negative 2 pi. All right, we have to remember that sine is an odd graph. So basically, we're going to reflect over the origin. So 0, 0 stays put. We have pi over 4, positive 3 becomes negative pi over 4, negative 3 when we go across the origin. Pi over 2, 0 is negative pi over 2, 0. 3 pi over 4, negative 3 will become negative 3 pi over 4, positive 3. Okay, and then negative pi, 0. And then we just repeat that same process again at pi over 4 distance. Excuse me, down 3. Negative 3 pi over 2 is at 0, a distance of pi over 4. Up 3, and negative 2 pi, 0. Okay. And we'll only be needing to work on our curves. All right, so the domain is all real numbers because our graph just goes on forever and ever. And our range is from negative 3 up to positive 3. Okay, so I said we'd talk about the amplitude. Okay, the height of our wave. Height of our wave is the amplitude. So, right, the height of the wave. Or you can see it over here as well. This would be the amplitude. And then the idea of the period. We started here at the origin. And then we had one complete cycle by pi. So this is our period. Okay, so let's try a cosine graph. Okay, again, period will be 2 pi divided by pi. Sorry, by b. In this case, 3. And that won't simplify, so we'll just leave that. Amplitude is the absolute value of a. In this case, negative 2. So the absolute value of negative 2 is 2. We're going to be multiplying by negative 2. We're going to be dividing by 3. Okay. All right. So as we go across, 0 divided by 3 is 0. 1 times negative 2 is negative 2. Okay. Division by 3. Okay. So I'm just going to come out to the side. Pi over 2 divided by 3 is the same thing as pi over 2 times 1/3. So I get pi over 6. And then 0 times negative 2 is 0. pi divided by 3, it's pi over 3, times negative 2 is positive 2. 3 pi over 2, I'm going to go ahead and bring that one out. 3 pi over 2 divided by 3 is the same thing as times 1/3. 3 divided by 3 is 1. Pi times 1 is pi, so that's just pi over 2. And then when we multiply times negative 2, we still get 0. Okay, and then 2 pi divided by 3 is 2 pi divided by 3. And 1 times negative 2 is negative 2. Okay, so what we should see is that we've had our period change from 2 pi to 2 pi over 3, which means we've had a shrink, right? It's much smaller. And then our amplitude of 2 tells us that we've been pulled up from 1, where cosine was before, and now we're at 2. Okay, so, and the negative out front tells us that we've had a reflection. Okay, so we're at negative 0, negative 2, pi over 6, 0, pi over 3, right, because this is 1 pi over 6, 2 pi over 6, and which reduces to pi over 3. We're at 2, pi over 2, 0, and 2 pi over 3, which is our next tick mark, at negative 2. Okay, so remember we have a curve going on here. It's not just like a little mountaintop. Right? Okay, and then we'll continue on. Okay, so that was 1, and so as I'm noticing, the spacing between each of the points is where each line has one of my coordinates on it. So I just follow that pattern, and so I know that if I go back up 2 and over 1, that's the location of my new point. Okay, and then up 2 over 1, and that's where the next one would be. And then down 2 over 1, and down 2 over 1. And that's going to be my next period of cosine. And then because we're still not at 2 pi, repeat. Up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. And now I'm at 2 pi, so this side of the graph is complete. Since cosine is even function, we're going to have symmetry across, so we're just going to have what's positive x becomes a negative x, but the y values will stay the same. So we're going to still see that same pattern of 2 and 1. So we just have this nice cosine graph. Okay, and just to kind of show you where we are, the original cosine was at 0, 1, and then came over to pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. Okay, so we had the kind of the sorry about that, but that was the shape. That shape has now been reflected, so that's why we're seeing this up. Okay, it's been stretched up to 2 instead of 1, and down to 2 instead of negative 1, and we've shortened up the period. We went from 0 to 2 pi over 3 right here. So that's our period. And then our amplitude, you can see, right, is 2. Okay, or we could count from here, right? Our amplitude is still 2. Okay, all right.